Hello everyone, I'm Yuujimotegi from Fukuoka Laboratory, Yamata University. Today I will be speaking on the topic of 3D chocolate printing for shape and text control. First of all, a 3D food printer is a device that can printing 3D modeling using food as a material, and it's expected to be a next generation device. In the future, it has the potential to solve a variety of problems, such as the following. So I focus on 3D printing using chocolate as a material, which has a great impact on product value in its appearance, entertainment value, and texture. 3D chocolate printers are gradually appearing on the market, but most of them focus only on the shape. And there are still few printers that enable modeling with texture in mind. For the purpose of our research, we will develop a chocolate 3D printer capable of modeling with two types of materials and other material extrusion methods. We will examine not only the syringe type, which is difficult to control the fine controllable material discharge, but also the gear pump type, which has less fluctuation of discharge volume with pressure increase in order to support fine modeling. After that, the chocolate with various internal structures will be printed, and the difference in texture between them will be measured by equipment and evaluated by sensory tests. In this presentation, we will report on the performance evaluation of the gear pump and the texture of black and white chocolates printed in a syringe type with different infill ratios. Next, the equipment used in this experiment was as follows. This is the overall view of the device. The cooling nozzles are attached like this, so that the chocolate can be cooled layer by layer. In a 3D printer, the number of steps for the motor needs to be adjusted to determine the definition of 1 mm extrusion. For a general 3D printer, there is a formula for calculating the number of steps, but for syringe and gear pumps, there is no specific method for calculation, so we decided to calculate it experimentally. In this performance evaluation, we measured the discharge volume when the rotation speed was fixed. The measurement results are shown here. Since the gear used in this time is an involute gear with a gear ratio of 1, we use the theoretical push-off volume per revolution here. From the table, it can be seen that the discharge rate is lower than the theoretical value at all rotation speeds. But there is no significant difference in the charge in discharge rate depending on the rotation speed, so it can be said to be stable. Also, as you can see in the video, the discharge stops as soon as the motor stops rotating, which means good controllability. Here is how to prepare for chocolate printing. In order to stabilize the cocoa butter crystals in the chocolate, the temperature is adjusted to make it glossy and mass-free. This table shows the tempering temperature for black and white chocolate. As the evaluation of texture, we conduct texture measurement. We took a total of 12 measurements, 3 for each of the 50 and 100 black and white chocolate infills. The test method was 2 times compression as follows. This video shows the actual measurement. First, this is a measurement result for 50% black. the infill 50% sample has good snapping properties, as the load is significantly reduced from the maximum load for all 3 test pieces. In addition, there was large variation in the appearance of the peaks. This may be due to the fact that the breakdown of the internal structure is not uniform each time, and thus the reproducibility is low. Next, this is the measurement result for 100% black. It can be seen that the force to break the infill 100% sample is larger and the waveform is more complex than the 50% one. This suggests that even after the blade begins to enter, it is not immediately destroyed to a large extent, but rather the blade penetrates while destroying the internal structure. Next is the measurement result for white 50%. Only 50, number 3, did not break even after compression to 80% thickness. So it was assumed to have no data. Since black chocolate has a hardness load of about 18 Newton, while white has a hardness load of about 30 Newton, it can be said that it is thought to be due to small fractures occurring on the surface. Also, the depressions are larger than in the black chocolate. This may have been caused by the many gaps in the surface of the 50% white infill, or by small fractures occurring on the surface. Finally, here are the measurement results for 100% white. While the white infill 50% has a brittleness of about 1.4 Newton, the infill 100% is more brittle at about 30 Newton. In addition, the structure deforms quickly at the first contact, probably due to its softness, and the load drops sharply when it reaches a certain point, suggesting that the fracture occurred here. The summary is as follows. In the future, we would like to do modeling and evaluation using a gear pump. That's all. Thank you for listening to my presentation.